Hey everyone, just one last video to finish up chapter 12 and talking about productivity and how things go from plankton to not plankton. So how I want to finish this up is talking about trophic levels and feeding stages. So we know from our previous videos, plankton, or from our previous lectures and videos, plankton, backbone of everything, right? They are the base, the base of it all, yeah? So because they're the base of it all, things have to eat it, or eat them, and then things eat them, and other things eat them, and other things eat them, and the cycle goes on and on and on. And life finds a way, if you will. So what I wanted to talk about to finish this all up are the trophic levels and feeding stages. So we know that plankton don't eat orca, but somehow, in some way, orca can eat plankton, right? So there's kind of a hierarchy or sort of period, or a pyramid, excuse me, with that. And just before we fully get started with that, fun facts. I have a mandala, what's it called? Tapestry here, and I also have a mandala tattoo. So I would like for you to tell me which one, where's that connection there? Okay, so on to it. Trophic levels and feeding stages. So it turns out actually that energy transfer as a whole is unidirectional and incredibly inefficient. So when I mean unidirectional, so energy is never created or destroyed. It just is transferred and transformed into a different type of energy. So in this case, we have radiant energy, or the sun, which is being consumed by producers. In this case, it could be phytoplankton, so, diatoms, dinoflagellates, or seagrass, algae, any sort of plant that's taking in the sun's energy and transforming it into their own energy and their own food and also oxygen. And then through chemical energy, consumers eat the producers. So even if you're in a carnivore diet, you're still eating your little vegetables because they're eating the vegetables. Thus, you end up eating the vegetables. You're welcome. So we go from radiant energy to chemical energy, which is then taken in by the consumer, and mechanical energy occurs when the things decompose, when things die, or heat energy, which is then, of course, dissipated throughout the water column. So when I say unidirectional, basically the consumer is not giving energy back to the sun, right? We're not like re-radiating things back towards the sun. Same thing with plankton and producers, that they only, energy is only coming in one direction. Yeah, so that's kind of the thing there. And the inefficiency of the food web is really quite wild to me. So this is a slide trying to show this idea. So say you have about 500,000 units of radiant energy, so of the sun coming in, there's a 98% loss of energy in that first level here. So going from sun to plankton, 98% loss. That is absolutely wild to me. Then continuing on through the food web, or the food chain in this case, you lose about 90% of energy along the way. So we're starting here basically, now that we're at a producer level, we have our phytoplankton, which are level 1 of trophic level 1. Then zooplankton eat the phytoplankton with a 90% loss. So we've gone from now 10,000 units of energy to 1,000 units of energy. And then the phytoplankton or zooplankton get eaten by smaller fish. And now we're from 1,000 down to 100 units of energy. And then the smaller fish get eaten by the bigger fish. Now we're down to 10 units of energy. And then humans consume the big fish, and now we are down to 1 unit of energy. So it is just really, really wild to me how much energy is lost through each level. And, now if you are, like, say, vegetarian or vegan or whatever, you can flex on your friends and say, haha, I eat more efficiently than you. And that's why I'm seeing gains when I go to the gym and you're not. Just kidding. There's obviously way more to gains than just that. But still kind of interesting to think about, right? If you're eating the energy from its source, if you will, then you are literally eating more more energy more efficiently. And there's actually a really interesting consequence of that for one of my favorite mammals in the ocean. We'll talk about that in a second. So this kind of implies that there is a food chain, which of course there is, but in reality it's more of a food web, and that it's more complicated than just from one to the other. And that's what this is trying to show here for herrings in particular. So we have our first trophic level for sure is definitely our phytoplankton, but our second level, our second trophic level can be a combination of zooplankton or other trophic levels of things. Honestly, like if whatever you're eating, like if a shark, say for example, just kind of takes a chomp of a fish, there might still be phytoplankton in that water that is also consumed by that, right? So it's not as like as simple as just going from one step to the other. There's more complicated aspects here, and then still just going up to higher trophic levels and things of that nature. Then we can finally get up to the big fish, which will eventually eat the herrings. So just wanted to explain that, that it's more complicated than just a food chain. And then how you will likely see this information on the final actually, is you'll have an image like this triangle here, this pyramid, if you will. So it will ask you the trophic level on one side, and then it will ask for examples on the other side. So I think this is worth a total of 12 points on your final. And so there's just things to consider, like the first level is the base of the pyramid, and the highest level, in this case, sixth level, is at the top of the pyramid. So 1 at the bottom, 6 at the top in numerical order. And then the level of consumers, or of course for the first level is primary producers, but for consumers, it's just kind of trying to understand who eats who in general in this particular sort of situation. So this is how you'll likely encounter this form of assessment on your final. But it's not just one big, one big pyramid here. It can be split into smaller pyramids. So this is really just for completeness of showing, different levels here, especially of open ocean versus coastal regions and upwelling areas, of like really the levels, the amount of levels that can exist, and the available energy units that can exist as well. Quite fascinating. The upwelling areas have much greater energy than the open ocean and coastal oceans. And like I said, all of this really gives way to sizes of animals. If you're eating at a more efficient level, you're eating more energy, so you can physically get bigger. And that is what we can see between our two different types of whales. So what we're looking at here are toothed whales, which common examples of toothed whales you may be familiar with, cetaceans as well, include killer whales, which are freaking gigantic, dolphins, narwhals, but then we have sperm whales, right? Sperm whales are the largest of the toothed whales, and we've talked about them at length before, but I thought, to bring them up, if you recall, they eat giant squid. So maybe that's one way that they're able to grow nice and big. Whereas our baleen whales are these larger whales here. So our blue whale, humpback whale, gray whale, and northern right whale. Of course, there's way more different types of species as well, but just wanted to show that here. And then it's really quite fascinating to me. It's just like our larger whales eat the smaller creatures like the krill, the anchovies, the plankton, right? Whereas, our orca, they eat seals, the same thing with dolphins, like they eat like bigger animals, but they don't physically get as large because they're not eating as efficiently. So I just find that to be super, super interesting, and like just ways that we can see and visualize that in Mother Nature is just really, really awesome. And really fascinating, I think, just because they're eating at a higher energy level. So here's our summary of Chapter 12 of Plankton and Productivity in the Food Web. So these are things that we've covered, things that you should know. I have copy-pasted this directly from your study guide. So you can use that to help aid you in prepping for the final, which will be in several weeks. So with that, thank you so much for watching, and I hope you have a wonderful rest of your week. Thanks.